well. Does that make sense to you? All right, so just keep that in mind. The more nervous Nelly you are, the more likely the pain's going to hurt, right? I personally think they've got this new I was just reading, there's this new types of experimental anesthetic out now. And you won't be able to find one here in Jacksonville, I know. I don't even know if it's approved yet, but what you do is you go in the dentist office, right? You drive in. They put a needle in your arm, start a drip. You pass out. Okay? The dentist works on you. He stops the drip. Within 5 minutes, you're walking out. What just happened? You're ready to drive. You're not droggy. You're just normal. All right? So you go in normal. You have a 30-minute root canal or whatever your trouble is. And you're out. You wake right up and don't need a driver. Go straight back to work. Don't even know what's going on. You know? Now, of course, that's ideal. Right? Now, what type of side effects and what types of problems they're going to run into? Who the hell knows? All right, that's what happened yesterday, right? And what I want to do now is you should have worked on this sheet. Who has worked on this sheet? Okay, so here's what we're going to do. We're going to go through this here. But before we go through this, I want to remind you that tomorrow we're going to have a test, right? We need to write that down. Test tomorrow. All right, now what chapters is it going to be on? Okay, 5, 10, 11, and 6. So chapter 5, how much does the atom weigh? Can we take the average atomic weights and all of that business? Chapter 10, electron configuration, 1s2, 2s2, 3s2, 4s2, on and on and on. Chapter 11, can we draw the Lewis dot structure? And what type of bond is it? Is it an ionic or covalent bond, right? And what is chapter 6? Naming. And that'd be what we're into right now. About 25% apiece. I mean, my tests are roughly weighted equal, right? I mean, I guess it'd be 26 points here, 24 points there, what the hell ever, but it's rough. All right, now, here's what I don't want to do. I don't want to go over this handout if you're not ready for me. Are you ready to go over this handout? All right. So let's get started here, and we'll take a break in a minute because I'm getting tired per usual. Okay. Shh. Sodium chloride, right? So what's this handout doing? It's walking you through it, right? And Bridget, if you want to just watch the handout there, you know, you don't see me over here picking my ear or something. All right, here's what we got going. This one's going to be sodium chloride. Yeah, and by the way, you guys chime in, right? Holler out, and if something ain't right, we'll stop. I'll get to the board and we'll discuss it. Calcium oxide. Aluminum nitride. Yes, ma'am. That is an L there for aluminum. That's a typo. All right. Now, on my test tomorrow, if something like that happens, you ask me. I certainly try not to make that happen, right? But one of the lab techs typed it up, and it's typo. So, you know, those things happen. All right, potassium. ASIUM. Sulfide. And this one here is called what? AHYDROGEN, hydrogen chloride. Now let's talk about this here. Why? Well, if it's a G for gas, it's hydrogen chloride. If it's dissolved in water, it's hydrochloric acid. If there is no distinction, you choose what you want to name it by. All right. All right, so everything in this series has been, what would you do if there's a metal with a non-metal? All right, any questions? Oh, here's one, ammonium sulfide. Any questions on the first page? Wonderful, let's go here. Okay, so what's going on here? Well, when I look at these, here's the commonality that I see. Everything there is multivalent. I know that copper has more than one oxidation state. Guys, I can't see that. Copper's got more than one oxidation state, This has a +1, +2, this has a 2 and a 4, and this has a 2 and a 4. So what does that mean? That means that I'm going to have to put a Roman numeral somewhere, or use the old-timey way. Okay? Now, chemists like me that are relatively young, of course some of you guys don't think 32 is relatively young, we use numbers. That's the way we like it. Now, old-timey guys, they like these OUSIC things. Right? All right, so here's what we got. Here we got a what? A copper 2 sulfide. Or alternatively, this would be a, well, let me think. Good, you guys are just running away. Cupric sulfide. That's right, cupric sulfide. And I absolutely refuse to get an answer key because if I ever can't do this, I need to walk out of the classroom. All right, so this is going to be copper 1, yeah, oxide, or cupris, O-U-S, oxide. Okay. And on an exam, the way I grade is either or you give me will be fine. All right, whatever you're more comfortable with. But now here's the catch. Let me tell you what the exam's going to look like. You're going to have a series of formulas. You provide the name just like this here. And then you're going to have a series of names, and you got to provide the formula. So if I say cuprous oxide, you're going to have to know what's going on, right? But if I just give you the formula, you can do whatever. And it really depends on what chemical supplier you buy the chemical from, how they label the bottle. You know, Strim and Alders, they label them a little different and whatever. Okay, this right here is mercury 2 oxide or mercuric oxide. This is 10-4. You getting that? Are you sure you didn't get 10-2? Be honest with me. Who wrote 10-2? Well, I have one honest person in the classroom. She's exempt from the final, right? She can leave right now and make an A. All right, here's what we got. Remember, when there's a metal, you have to reduce. All right? So, if you're talking about 10, it has a +2 option and it has a +4 option. Everybody happy? Okay, now oxygen has a -2. Now, does oxygen always go -2? No, I mean, in peroxides it doesn't, in superoxides it doesn't, but in a normal compound that's binary, it goes -2. All right, here we go. Playing switcheroo here. Here we go. Here we go. That's going to leave us SN2O2. Do we have to reduce? Yes. That would be SNO. What is the name of SNO? 10-2 oxide. Are you with me? Is that what we got right here? Okay, that was a bad idea. And by the way, that's why we got scratch paper, right? Tinker through these things. Here we go with a 4. Here we go with a 2. SN2O4. Look at here. We reduce this. Yeah, 10's an honest to goodness metal, right? So that's going to be what? SNO2. What's the name of this guy? 10-4. All right, we get into truck driver language. Oxide. 10-4 oxide. Are we good?
Why is it 10-2? How do you get 10-2?
How do you get 10-2? The 2 comes from the oxidation state of the metal. Okay, that's what the Roman numeral comes from, the oxidation state of the metal.
And they don't cancel each other when they're...
Oh yeah, SNO is the final answer.
Yeah, but...
Yeah, they cancel.